Good morning, students. Currently, we are studying chapter waves, and we did some part of the waves. Let me recall some important points. Last time we studied that waves are energy carriers, and they carry energy from one place to another with the help of vibrations of particles of the medium. And when they are doing so, the particles they just vibrate about their mean position and they do not go with the energy, so they are just mean of transporting energy from one place to another. There are two types of waves on the basis of behavior of particles of the medium. One is transverse wave, the other is longitudinal. It is a type of waves in which particles of the medium vibrate perpendicular to wave motion, for example light waves. And in longitudinal waves, the particles of the medium they move or vibrate parallel to the wave motion, for example sound waves. Again, there are two different types of waves, and they are mechanical waves and electromagnetic waves. For mechanical waves, there is a requirement of medium to propagate, for example sound waves, and for electromagnetic waves there is no need of material medium, for example light waves. Now for today's lesson, the learning outcomes are: you should be able to describe important characteristics of waves, and those characteristics of waves are familiar to you. For example, frequency, time period, amplitude, displacement, etc. So first part is the characteristics of waves. You did these characteristics for pendulum or for oscillatory motion. Here we are going to revise it for waves. Then we are going to derive a very important formula which is known as a wave equation as well, and that is V is equal to F lambda. V is speed or velocity, F is frequency, and lambda is wavelength. And by applying this formula we can find out any parameter. Suppose that if these two values are given, we can find out lambda, etc. Then interpret and explain displacement distance graph and displacement time graph. So the first term is time period. Let's recall this time period. We did it in chapter number 1, if you remember. It is a time taken by one complete wave to pass through a certain point. So the time taken by a wave, one complete wave to pass through a point, is known as time period. And previously you know that the time period is denoted by t and its unit is second. Frequency is number of waves passing through a point per second. Last time you studied this and you defined it like number of oscillations per second or number of cycles per second. Now you are going to mention waves in it, so number of waves passing through a point per second. And we know that frequency is denoted by F, its unit is hertz or Hz. And the relationship between frequency and time period, they are reciprocal or inverse. If there is a wave whose time period is larger, then its frequency will be smaller, and vice versa. Now if you want to see the unit of frequency, which is hertz, the unit of time period is second, so 1 over second becomes second inverse like this, and second inverse is named as hertz in System International. There is a question: a source of waves generates 100 waves in 2 seconds. Find the frequency and time period of waves, or time period or frequency of source. So first, for example, how to find out time period? The formula of time period is time taken divided by number of waves. The time taken is 2 seconds and the number of waves are 100. So 2 over 100 gives you 0.02 seconds. So this is the time period of waves, and you need to remember this formula. Frequency of waves is F is equal to 1 over t, means 1 over 0.02 seconds. This second moves up to numerator from denominator, and it becomes s minus 1, which is hertz further, and this 1 over 0.02 gives you 50. So the frequency is 50 Hertz. We can also calculate frequency like this, that the frequency of the source will be equal to number of waves, which is 100, divided by the time taken, which is 2 seconds. And 100 over 2 gives you 50, and when second moves up, it becomes second inverse, and second inverse is known as Hertz in System International. So still the answer will be 50 Hertz. So the purpose of this question was to show that how to find out time period and frequency. Now next terms or characteristics of waves is crest. It is the highest point of a transverse wave on a wave. It is called crest. For example, it is a wave. We know that suppose that this is the mean line of the wave, then this point is the highest point and it is known as crest, and this distance is known as amplitude. Point of maximum amplitude on transverse wave is also known as crest. So it is crest. Opposite to crest there is trough. So it is point of lowest, the lowest point of transverse wave is known as trough. So this is trough. It is lowest, it is highest. So it is crest, it is trough. What is amplitude? It is the maximum displacement of a point on a wave. This distance is amplitude, and amplitude is denoted by A. Its unit is meter. Displacement is the shortest distance of a point on a wave. Suppose that if I take a wave like this, suppose that it's a wave, it's a larger wave, and we take this point, which is crest point, and this is amplitude. But if you take, for example, a point here, then this is not amplitude. This is smaller distance than amplitude and is known as shortest distance, known as displacement. Phase. Suppose that here we have a transverse wave in which there is a crest and trough, and so on. Now we take points on this wave. Suppose that I take this point and this point. They are said to be in phase. Why? Because they are having same distance from mean position. They are having same direction of motion and same velocities. So any 2 points on a wave which are having same displacement from mean position, same direction of motion and same velocities, they are said to be points in phase. If suppose that I take this point, so with this point is in phase, and these 2 points are at a distance of 1 wavelength apart as well. Wavelength is a term which we will study next. So these are also 2 points in phase, and these are also 2 points in phase. Compression. It is the region of high pressure in sound waves. Sound waves travel in the form of successive compression and rarefaction. What is compression? Compression is a region of high pressure, or a high pressure region is known as compression, where the medium is crowded. The distance between the layers of medium that is very small. It is known as these layers are compressed. That is why it is known as compression. While here they are relaxed, so it is known as rarefaction. Rarefaction is the region of low pressure. Compression is the region of high pressure. What is wavelength? It is distance between 2 successive crests. Again, take transverse wave and make crest and troughs on it, and so on. So the distance between two neighboring crests, this distance is wavelength, denoted by Greek letter lambda, and the distance between these 2 points is also known as wavelength. The symbol for wavelength is lambda. Its unit is meter. On longitudinal waves, we can say that the distance between 2 successive or neighboring compressions or rarefaction is also known as wavelength. Suppose that it is compression where the layers are crowded, then here is rarefaction, the same layers are relaxed, suppose, and then again we have compression. So after compression there is rarefaction, and after rarefaction there is compression, and so on. So here is again rarefaction. They are geometrically same, so we can call it is compression and compression, and the distance between the centers of these compressions is also known as wavelength, or the distance between the centers of rarefaction is also known as wavelength. So distance between two successive compressions or rarefaction is called wavelength as well. What is speed? Previously we know that speed is distance covered by a body per unit time. Here it is distance covered by waves per unit time. So speed is distance covered by waves divided by time. In case of waves, the distance is replaced by wavelength and the time is replaced by time period. So we get lambda divided by 2, means wavelength divided by time period. This can be written as 1 over t into lambda, and previously we saw that 1 over t is frequency. So instead of this we write f. The formula becomes v is equal to f lambda. V is speed and this is f is wavelength, and lambda is wavelength and f is frequency. So this is our wave equation, v is equal to f lambda. We will use it in questions. Now let's summarize the terms. This is a point and it is at highest point from mean position and is called crest, and this is the lowest, it is known as trough. These black dots, they are said to be points in phase, and the distance between this crest and this crest is known as wavelength, or the distance between this point and this point is also known as wavelength. Now let's start displacement distance graph. If you remind to yourself a wave which you have produced with the help of a rope, when you were vibrating your hand up and down, you saw that a wave starts traveling from hand towards the wall. So the wave travels in this direction and it covers some distance. That distance is taken here in centimeter. While the vibration of hand, it covers displacement. So on this axis we took displacement in centimeter and distance in centimeter. Now the numerical questions on the basis of such graph. Suppose that you are asked that this is a graph given and what is the wavelength of the wave. So what do you do? On x-axis distance is given, and if distance is given we can find out wavelength, because wavelength is nothing but distance between 2 points in phase. So this first point and this second point, these 2 points are 5 points in phase. So this distance is wavelength, which is lambda, and that is equal to how much? That is 50 centimeter. So the answer of this part is 50 centimeter. And it is calculated from x-axis. What is the amplitude of this wave? This much is the amplitude of the wave, which is nearly 4 centimeter. The next is, if the time period of the wave is 1 second, if the time period is equal to 1, so it is 1 second. What you do? Find out frequency. So for frequency we use 1 over t. So frequency is equal to 1 over time period, and time period is 1. So 1 over 1 gives you 1 hertz. So it is equal to 1 divided by 1, and this becomes 1 hertz. So this is the solution of B part. What is speed of waves? Speed is equal to f lambda. So it is f and there is lambda. What is frequency? That is 1 hertz. So here we replace 1, this frequency. And what is the wavelength? Wavelength is 50. So what we get speed of waves as 50 centimeter per second. So the frequency is calculated, that is 1 hertz, and speed is 50 centimeter per second, because I took this lambda in centimeters. Next is, what will be the wavelength if the wave frequency is increased to 5 hertz? The frequency is 1 hertz. If we increase the frequency to 5 hertz, then what will be the wavelength? It means we need to use this V is equal to F lambda again. From this time we need to calculate lambda. So lambda from this equation will be equal to speed divided by frequency. And we know what is speed. The speed is calculated, and that was 50 to 1 is 50. So here I write 50, and the frequency is increased to 5 hertz, which is 5 here. So that gives you 10 centimeter. Here the wavelength is 50, while here now the wavelength is 10. So by increasing frequency from 1 to 5 means 5 times this one. The frequency is increased 5 times, so wavelength is decreased from 50 to 10. That is, wavelength is also decreased 5 times. One is increased, the other is decreased, because when we say V is equal to F lambda, so lambda and F, they are inversely proportional to each other. When the frequency is increased 5 times, the wavelength is decreased 5 times. So the next thing is displacement time graph. On this axis now we have time, not distance. So this is not distance, it is time. So displacement time graph. And how this will be used? From this we can see that till here is one wave completed. So this is one crest and one trough, and a wave is completed over here. So the time period of the wave is 0.8 seconds. And similarly, from this we can find out the amplitude as well, which is in this case nearly 4 centimeters. If you want to solve numerical problem on this, then what is the time period of the wave? The time period of the wave is taken from here, that is 0.8. Means this one cycle takes a time 0.8 seconds. So this time period is equal to 0.8 seconds. This is our first answer. The next is, what is the frequency of the waves? So from time period we can find out frequency easily, that is F is equal to 1 divided by T. So it is 1 divided by T, and T is how much? That is 0.8. So we get F is equal to 1 divided by 0.8, and by calculating this with calculator you can find out the frequency of the waves. If the wavelength of the wave is 20 centimeter, if the wavelength is given, we need to find out the speed of waves, and we know that speed is equal to V is equal to F into lambda. So F is here, which is 1 over 0.8. So we write here this is equal to 1 divided by 0.8. This gives you frequency. And this, the wavelength that is given, this is 20. So by dividing 20 on 0.8, we can find out the speed of the waves. So this was all about. Thanks for watching.